So, hello students, welcome back. Today we are going to see the most important topic, that is catalyst and reagent, and especially we already seen this topic previously, but today's session we will be seeing all important reaction in this chapter. And this is important because this type of reactions are asked in most of the entrance exams like JEE, NEET, SET, even national eligibility test, then GATE, BSc also this topic is there. So most of these exams, such type of important reactions are asked in the exams. So let us start with today's topic. So such type of questions are asked in the exams, that is, complete the following reactions. So as you can see here on the screen, that you can see three reactions which are given and some question marks are there, or A, B is written here. That indicates that we have to basically write the products. Okay, so here you can write the products. So the first one is benzene ring, and there is reagents given, which is H2PtO2, that is platinum dioxide, and acetic acid. So you can find this catalyst H2PtO2 is nothing but your Adams catalyst. Okay, so one by one all reactions we are going to see, but the main thing in such type of questions are we should know what is there written on the arrow. First thing is we have to see the catalyst or reagent given on the arrow. Once you understand what are the reagents or catalysts given and what is its role, okay, so what is its role, how it is going to take part in the reaction with the starting material, that we have to first try to understand, and then we can write the products. Okay, so here in second reaction also there is a benzene ring, then on arrow if you see there is ranny nickel and hydrogen. So again this catalyst used for reduction. So you have to write what is the A as a product, then that A is going to further have some reaction. So here I think I forgot to write, but it is oxidation. Okay, what is going to be in the second part of this reaction? So it undergoes oxidation. So let me write here oxygen. Okay, so there is oxidation which is going to take place. And then third one, if you see again ranny nickel or Adams catalyst they have given, and in the starting material you can see there is a nitrile, that is cyanide, C triple bond N. So one by one let us see how the reaction proceeds.
So let us see the answers of the reaction. The first one is benzene and Adams catalyst. So Adams catalyst is used for reduction, and it is going to reduce all pi bonds of benzene ring, giving cyclohexane. So all pi bonds, that is double bonds, have been reduced and hydrogens are getting added. So this is basically hydrogenation, which is giving you cyclohexane. Now the next is benzene ring and ranny nickel hydrogen. So again hydrogenation, it is having the same role like your Adams catalyst. Ranny nickel and hydrogenation takes place, where hydrogen gets added on the pi bonds of the benzene ring, and we are going to get cyclohexane. Now if you see the next reaction is basically there is, as I told you, oxidation taking place. Okay, so here the oxidation of cyclohexane, and while oxidation taking place in the second step, you will find that there is breaking of the cyclic ring at this position, and you are getting two carboxylic acid. So the name of the product is adipic acid. So if you count these carbons, there are 6 carbons total, out of which 2 are carboxylic acid. So it is a dioic acid, and the product name is adipic acid. Now the next one is you can see benzene ring with a cyanide. Okay, CH2CN, that is either we call it as nitrile or cyanide, and on arrow ranitidine and Adams catalyst, or Adams catalyst we can use. So either of it if you use, or if it is there in the exam, you should know that both of them are going to reduce the cyanide, that is triple bond, and triple bond will be reduced to the single bond, where hydrogens gets added on each atom, that is carbon and hydrogen. So one hydrogen will get added on carbon when one pi bond is going to break, and other will go on nitrogen. Similarly, the second pi bond also breaks and we will get hydrogen added on either of the side. Okay, and this way the cyanide has been converted into amine. So here you will find that we are going to get a primary amine, so a benzene ring, CH2, CH2, CN. Okay, so this way you are going to get the product, that is primary amine. So let us see the next one, fourth one. In the fourth one you will find that we have a ester group and a benzene ring, and on arrow if you see there is ranitidine at 100 atmospheric pressure and 50 degrees Celsius. So we know that ranitidine does the reduction of the benzene ring. So let us find out whether it is going to even reduce the ester group. So let us see the answers. So if you see the fourth question, ranitidine, which is going to only reduce the benzene ring, not the ester group. And while studying the question answers, we have seen that ranitidine can only reduce the pi bonds, and it cannot reduce esters, as well as it cannot reduce carboxylic acid. Okay. So the next question, fifth question, is benzyl chloride plus H2, and arrow it is palladium barium sulfate. So whenever you see palladium barium sulfate, children, last time I have told you that it should strike that it is Rosamond reduction. So basically Rosamond reduction is used in which palladium and barium sulfate catalyst is used. So this acyl chloride or acyl halide is converted into benzaldehyde or aldehyde basically. So this group, that is COCl, is converted into COH. So here the product which you are going to get is benzaldehyde. So this is the most important name reaction which is asked in so many entrance exams and competitive exams. So Rosamond reduction is barium sulfate. There is a reduction of acyl chlorides or acyl halides to aldehyde. Similarly, sixth one is again the Rosamond reduction, because if you see on arrow it is PD, BaSO4 and hydrogen. Apart from that, in the starting material there is acyl chloride, COCl, which is converted into COH, that is aldehyde. Okay, so your Rosamond reduction is not reducing your pi bonds, but it is only reducing the acyl chloride. So again this is a partial reduction. Partially it is reducing only the acyl chloride, not double bonds. Okay, so this you have to remember. So let us go to the next part one. So the 7th, 8th, 9th question, if you see, the 7th one is 2-butane and the catalyst. Now we have to always see the catalyst or reagents which are given on the arrow. So here it is barium calcium carbonate. So barium calcium carbonate is used as a name, one catalyst which is used here, and it is known as Linda's catalyst, where lead acetate is used. Then similarly the next one, if you see, it is sodium borohydride. Then 9th question, they have used lithium aluminum hydride or red aluminum. So all these are going to have reduction. Okay, all these are the reducing agents, but some are selective reducing agents, some are having peculiar stereo selectivity. Now let us see which is stereo selective, which is going to partially reduce, which is going to selectively reduce among this. Okay, so from arrow it is clear that arrow, whatever catalyst they have given or reagents they have given, it is clear that all the 4 reactions are reduction reactions. Now only thing we have to see whether they are going to reduce aldehydes, benzene ring, or double bond or triple bond, what they are going to reduce and how is the product. Let us go to the answers. So the seventh one, it is 2-butene, that is there are triple bonds, so obviously the reduction will take place as triple bond, but we have to find out whether it is all the 3 pi bonds will triple bond is going to reduce to single bond, or whether it is going to reduce partially. So if you see the reagent, that is lead and calcium carbonate in the presence of lead acetate, which is, just now I told you, it is called as what? Lindahl's catalyst for partial reduction. Okay, so you should always remember what reagents or what catalyst they have given on the arrow. So here it is lead and calcium carbonate. So this combination used for partial reduction. That means it is going to partially reduce only one pi bond out of three bonds. That is triple bond. It is going to reduce only one single pi bond. Okay, and the product we are getting is cis. So this is basically a reaction which is stereoselective. The meaning of stereoselective means the hydrogens will be added as a syn addition, that is from same side. Both the hydrogens will get added from the same side of the carbon in a plane. So you will be getting a cis butene as a product. Now the next one is p-nitrobenzaldehyde. P-nitrobenzaldehyde, the reagent given is sodium borohydride. Again, it is a reducing agent, but it is a mild reducing agent. Okay, so being mild reducing agent, it is not going to reduce your nitro group. It is only going to reduce ketones and aldehydes. We have seen this in our MCQ. Okay, sodium borohydride being mild reducing agent only reduces what? Aldehydes and ketones. It does not reduces nitros, then acid and ester group. It cannot reduce these groups. So the aldehyde here, CHO group, has been reduced to alcohol. Okay, so it is CH2OH. The aldehyde group has been converted into alcohol, that is CH2OH. Now the next question is cinnamon aldehyde, where you will find there is a double bond as well as aldehyde, but on arrow if you see, it is lithium aluminum hydride. So when you see lithium aluminum hydride, immediately it should strike that it is a strong reducing agent. Okay, so lithium aluminum hydride is a what? Strong reducing agent. So it is going to reduce both pi bond as well as aldehyde group. So here you can find it is going to reduce this pi bond as well as aldehyde group. So C6H5, so the product if you see C6H5, then this CH, it has converted into CH2, single bond CH2, and aldehyde group, that is CHO group, has also been converted into alcohol, that is CH2OH. So basically lithium aluminum hydride being a strong reducing agent has reduced both pi bond as well as aldehyde group, and the product we are getting is 3-phenyl 1-propanol. So basically you will start counting from the alcohol group, that is 1, 2, 3. So the first carbon is alcohol, OH group, so we call it as 1-propanol. The parent group is 1-propanol, and on the third carbon if you see this carbon, there is a phenyl ring, so it is 3-phenyl 1-propanol. So again it is a reduction reaction. Then the 10th reaction, if you see, complete the following reaction, it is CH3CN, so it is methyl cyanide or methyl nitrile. Again lithium aluminum hydride being a strong reducing agent is going to reduce your cyanide group to amines. So the double bonds, pi bond, out of 3 bonds, 2 bonds are going to get reduced into single bond, that is you will be getting CH3, CH2, NH2, ethylamine. So you can see here, if you want to increase the number of carbons from the starting material, we can use reduction for cyanides. So methyl has been converted into ethylamine. Okay. Now the next one, 11th question, if you see, now the reagents which are there given here, just go through the reagents. One is selenium dioxide. In the next question also it is selenium dioxide. Then, okay, so here selenium dioxide is used as a reagent. And in 13th, if you see, there is a reagent which is known as NBS, that is N-bromosuccinamide. And on arrow it is carbon tetrachloride and benzoic acid. Okay, C6H5COOH is benzoic acid. So all these if you see the reagents, out of three, first two is oxidation, where oxidation is going to take place, but at the selective positions. And NBS, it is always used for allylic bromination. So whenever you have to solve such questions, you should know the role of the reagents, what they are going to do on your starting material. All these 13 questions which are mostly asked in the exam for complete the following reaction. So students, today we have seen some reactions based on reduction and oxidation, and these are very important questions which are asked in the examination, either in the MCQ types of questions or match the pair or complete the following reaction. So if you want to excel in your examination, do watch the other videos which have been uploaded on the channel, that is polymer solved question answers, MCQs, objective type of questions. These videos have been uploaded for catalyst and reagent, and the numericals based on NMR spectroscopy, that has also been uploaded. So do watch, like and subscribe, and do share to your friends, and let me know. You can give the comments. If you want the notes, you can just, in the PDF form, you can just comment below, and keep watching. Thank you so much.